Hi students, in this lecture we are going to discuss speed of a sound. So earlier we have discussed speed of a sound equal to root of E by rho, right? So up to here we have discussed. So we got V equal to root of B by rho, where B is bulk modulus of the fluid. And in general, that is written as root of E by rho, where E is modulus of elasticity. In case of solids, writing that in the place of Young's modulus for fluids, that means liquids and gases, we take bulk modulus. So up to here we have discussed, right? Now see next one. So when sound is propagating, there are compressions and rarefactions, right? When sound is propagating in the medium, there are compressions and rarefactions. So Newton assumed that the changes are isothermal. He assumed that the changes are isothermal. And we know in isothermal process, bulk modulus equal to pressure of the gas. See how is that? So we want to calculate now pressure of the, bulk modulus of the, for the process. So he assumed that changes are isothermal. That means, that means that means PV equal to constant. We want to calculate bulk modulus for isothermal process, right? Now differentiate this dP into V plus P into dV is equal to 0. Okay, right. From this, see what we can write. From this, what we can write. Actually, we want bulk modulus equal to minus delta P by delta V by V, right? So here what we can write, delta P by dP equal to minus P dV by V, right? Now taking this dV by V, this side. So dP by delta V by V equal to P, right? Minus P. That means now this is equal to P, right? That means in isothermal process, bulk modulus is equal to pressure of the gas, right? And according to Newton assumptions, so speed of a sound will be, if you take now this value, see what we got, V equal to root of E by rho, right? Root of B by rho. In the place of B, writing now pressure of the gas, root of P by rho. So by taking now pressure of the gas and density of gas, he got value approximately 280 meter per second. By taking this value, he got speed of sound approximately 280 meter per second. But practically, speed of sound is around 330 meter per second. That means this is not matching with practically what we observed. Later, a scientist called Laplace, he made a correction by assuming that the changes are adiabatic. So when they are compressing, having rarefactions, the changes are adiabatic. So in adiabatic process, you can calculate now here bulk modulus for adiabatic process. So taking P V power gamma equal to constant. So P V power gamma equal to constant. Now differentiate that. So P gamma into It is V power gamma minus 1 into dV plus V power gamma into dP equal to 0. From this, bulk modulus is equal to gamma times pressure of the gas. You can just make calculation, okay? Finding delta P by delta V by V from this one. Then bulk modulus comes out to be gamma times pressure of the gas. And if you take this value, if we take this value, V equal to root of, in the place of bulk modulus, gamma P by rho. And he made calculation by taking this one and that value matching with practically what we are observing. That means that the assumption taken by him, means by Laplace, is correct. Okay. That means we are going to use now the relation gamma P by rho. Otherwise, from gas equation, in the place of P by rho, we can write gamma RT by M from gas equation. So gamma P by rho, or in the place of P by rho, writing RT by M. Okay. Or same thing we can write gamma R, gamma KT by M. And see what is now this? This M is molecular weight of the gas, right? Coming to the small m, this is now mass of the molecule, right? This is mass of the molecule. So either we can take in terms of molecular weight or in terms of mass of the molecule, right? So these are relations we are going to use to calculate speed of a sound. Okay, right. Now you can see notes for this one. Yeah. So Newton assumed that the changes are isothermal, and for isothermal process, bulk modulus is a P, and taking that value, it is not matching. Later, Laplace assumed that the changes are adiabatic. In adiabatic process, bulk modulus is gamma times P, and taking that, we are going to get V equal to root of gamma P by rho. In the place of P by rho or T by M, or it is equal to gamma KT by M, and M is molecular weight of the gas, or small m is mass of the molecule, right? So this is what we have discussed, right? Let us move to next one. Yeah, next one is intensity. So how we calculate now intensity? So we are knowing that intensity means energy per unit area per unit time, right? Now see how we calculate that. Right, intensity we want to calculate. First calculate power. Power equal to F bar dot V bar. This is what we have learned in mechanics part, right? In work energy power. Let us take between these two angles 0. What I can write in the place of force, it is delta P, pressure difference. Students, remember this P stands for power, okay? And this delta P is a change in pressure. Pressure difference into cross section area is S. That is a force. Force into velocity. Velocity is now, if you take y equal to a sine omega t minus kx, then velocity will be dou y by dou t. See how much it comes? It is a omega cos of omega t minus kx. Now simplify this and take in the place of power. Power by area gives intensity. Intensity equal to delta P. In the place of delta P naught into cos omega t minus kx into a omega cos omega t minus kx. Okay, right. Now this is delta P naught, delta P naught. What else we are having here? A is right. In the place of A, I want to write by using ABK is equal to delta P naught. I told you to remember this one, right? Because we are using this one in solving problems. Delta P naught equal to ABK. In the place of A, I want to write in the place of A delta P naught by BK in the place of remaining is omega into cos square omega t minus kx, right? Let us take average intensity. Then for one cycle, for cos square function, average value is a half. So this is now half square of delta P naught. See, in the place of omega by k, I can write V. Okay. In the place of B, see what we can write. So we have velocity equal to root of B by rho, right? So from this we can write B equal to V square into rho. Okay. Now substitute that in the place of B. It is V square into rho, right? And that becomes delta P naught whole square by 2 rho V, right? This is average intensity. Okay. Square of delta P naught by 2 rho V. Rho is density of medium and V is velocity of sound. Velocity of sound in that medium. Okay. Right. Now see notes for this one. Yeah. So here we have taken y equal to a sin omega t minus kx and delta P. Then power is f into V. We have taken here between f bar and v bar angle 0. Okay. Then substitution the values of delta P and V. And we got square of delta P naught by 2 rho V. Right. Rho is density of medium and V is the speed of the wave. So this is about intensity. Okay. Right. Now see the next concept. Yeah. This is sound intensity level. So we measure sound in terms of decibel. It is one special unit. dB. dB stands for decibel. Okay. So this is defined as sound intensity level equal to 10 decibel into log I by I naught to the base 10, where I naught is 10 power minus 12 watt per meter square. Okay. Suppose if I am taking in the place of 5, let us say 1 watt per meter square. If I becomes 1 by I naught, okay, it becomes now 10 power 12. That means L value becomes 120 decibel. So sound is measured in terms of decibels. We are taking one log scale here, okay, log. Let us understand by solving few problems basing on this. Okay, right. See problems basing on velocity of a sound intensity. Okay, right. So the first problem, it is basing on speed of a sound. If the speed of a sound in oxygen is a 450 meter per second, What will be the speed of hydrogen at same temperature and pressure? Right. You are given for oxygen 450. We have to calculate for hydrogen at same temperature and pressure. Right. Right. See how we solve this problem. Same temperature and pressure. What relations we're having here? Let us understand first. V equal to root of gamma P by rho. Gamma P by rho, or this is taken as root of gamma RT by M, or this is taken as gamma KT by M. Okay. Now you are given here, right? It is given hydrogen and oxygen, right? For oxygen, speed of sound for oxygen 450 meter per second. We have to calculate for hydrogen what is velocity. Okay, right. Now we can see here, right? Given same temperature, since both are diatomic, gamma same. Now only changes it is molecular weight. Only changes molecular weight. So we can write V proportional to 1 by root m. V proportional to 1 by root m. Okay. That implies velocity of hydrogen by velocity of oxygen is equal to root of, this is now oxygen, molecular weight is 32 grams and hydrogen is 2 grams, right? This is now 16, this is a 4. So that implies velocity in a hydrogen is 4 times, right? Given how much oxygen? 450. Therefore, speed of sound, it is 1800 meter per second. Okay. Like this, we can solve it. Okay. And if you observe one more condition, given same temperature and same pressure. See why they mentioned both are same. From gas equation, we can see PV equal to nRT. Given same temperature, same pressure. That means volume same, right? So when you are taking a given volume, and we are taking a given volume, right? Density will be density equal to mass by volume. Okay. So if you are taking now, let us take 1 mole. 1 mole means both having same volume. That is 22.4 liters, right? And volume same. Density proportional to mass. Density proportional to mass, right? Then we can write in the place of density, it is a mass. That means now velocity proportional to 1 by root rho, right? And in the place of what we are writing, because same volume, in the place of writing now, it is mass of the gas, right? Root here. So like this also, we can solve the problem, right? Okay, now see next problem. And this also basing on speed of a sound. It is a found that an increase in pressure of 100 kilopascal causes a certain volume of water to decrease by 5 10 power minus 3% of its original volume. Then the speed of a sound in the water is about. So first understand the given data. It is a found that an increase in pressure. What is it? An increase in pressure of 100 kilopascal. So delta P is given. Delta P that causes a change in volume of water by 5 10 power minus 3%. Means we are given delta V by V into 100. Okay. Then we have to calculate speed of sound in water. Density of water is 10 power 3. Let us see how we are using this data to solve the problem. Delta P 100 kilopascal. This is a 5 10 power minus 3%. Right. See the given data first of all. Right. First I'm writing here given data. Delta P equal to 100 kilopascal. Right. Means into 10 power 3 pascal. Delta V by V into 100 is actually negative also because volume is now decreasing. Okay. That is equal to 5 10 power minus 3. Okay. That means how we are finding speed of a sound. Speed of a sound equal to root of P by rho, right? We are given now this information to find bulk modulus. Okay. I am repeating. We are given delta P percentage change in volume to measure or to calculate bulk modulus. So we know bulk modulus is delta P by delta V by V, right? I am writing here V equal to delta P by minus delta V by V. That means delta P 10 power 5 minus delta V by V. It is 5 10 power minus 3 by 100. Okay. See this value comes out to be how much? 10 power 5. This is 100, 10 power 7, 10 power 7, 10 power minus 3, 10 power 10. Or it is 10 power 10 means I can write 2 10 power 9 Newton per meter square, right? Cross check one's calculation. 10 power 5. This is a 2 10 power 7 plus 3 10 power 10. 10 power 10 by 5 or 2 10 power 9. Use that one here. Root of 2 10 power 9. Rho value density of water is 1000, right? It is now root 2 into 10 power 9 and 3. 6. 6 means 3, right? 3 meter per second. Or if you take root to 1.414, 1.414 meter per second, right? So first what we are doing is delta P given, delta V by V also given. So immediately we have to get a thought like that is given to calculate bulk modulus. And once it is known, we can find velocity of sound or speed of a sound. Okay. So I hope you got clarity. Let us go for next problem. This is basing on sound intensity level. the sound intensity level at a point 5 meters away from a point source is 40 decibel. What will be the level at a point 50 meter away from the source? What is it? Given sound intensity level at a point 5 meter away from a point source. Here important one is point source, right? Point source is 40 decibel. What will be the level at a point 50 meter away from the source? So why this point source is important? Because in case of point source, intensity proportional to 1 by r square. I will write here 550 and this is a 40, right? Right, see how we are solving this. Right. Given 40 decibel when distance is a 5 meter away. What is now intensity when distance is a 50 meter from a point source? So in case of point source, intensity proportional to 1 by r square, where r is distance from point source, right? And we have definition for sound intensity level, L equal to 10 decibel log, so this is log log I by I naught to the base 10, right? So now we have to calculate what is the final value. Then see what I can do here. Writing there I2 by I1, I2 by I1 is equal to R1 by R2 whole square, right? See from this what we get, I1 by I2 equal to R1 by R2 means a 5 by 50 whole square. That means it is 1 by 100. That is I2 by I1. Okay. Use that result now in this case. L equal to 10 decibel log. Let us take this is L2. Okay. L2 equal to 10 log. In the place of I2, it is I1 by 100. I1 by 100 by I naught to the base 10. So how this is now written? 10 decibel log 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 I1 by I naught to the base 10 minus log. See how this is written now. I1 by naught. This is log 10 power I1 by 100. It is I1 into 1 by 100. So 10 power minus 2. 10 power minus 2 to the base 10. Okay. Right. See carefully once what we have done here. I have taken this as I1 by I naught into 1 by 100. I am writing separately here to make it clear. I1 by I naught into 100. Okay. This is now I am taking this as a 1 by 100 is taken as B. So A into B. So this is now log AB. What is this? This is log AB. In that, what is A? I1 by I naught is A, right? And remaining 1 by 100 is B. So log A minus log B. So log AB equal to log A minus log B, right? You can see first part 10 decibel, first part 10 decibel log I1 by I naught to the base 10 minus 10 into this becomes see how much? 10 into minus 2, right? Yes or no? It becomes minus 2. 1 by 100. Wait. Log A plus log B. This is log A plus log B. Okay. I have taken mistake there because this is A into B. What is this? This is A into B. So log A plus log B. Okay. Now the first one given as 40 decibel. So 40 decibel minus 20. This is now 20 decibel. That is our final answer. So here key point is point source. Therefore, intensity proportional to 1 by R square. From that, we got relation between I1 and I2. And using definition part, 10 decibel log I by I naught. Okay. So I hope you got that clarity.